Okay, this is quiz number 10. The question reads, consider the function g of x equals x cubed minus 3x squared in the interval from -1 to 4. Okay, the first question says, find the critical points of the function g of x in the interval. And they even say a critical point is a point where the derivative of the function is either equal to 0 or undefined. So right away we know we need to take the derivative. So if we do that, g prime of x, we're just going to use the power rule here. So we have the derivative of x cubed, that's just 3x squared. The derivative of 3x squared is 6x, so I have my derivative is 3x squared minus 6x. Now I need to find out where that derivative is 0 and where it's undefined. So first of all, if I set up 3x squared minus 6x is equal to 0, I get that 3x squared is equal to 6x. Now notice I know that x star is equal to 0 satisfies this. So now I'm going to consider when x is not 0. So I can divide both sides by x because x is not going to be 0. And I get 3x is equal to 6 or x is equal to 2. So my two solutions are x star is 0 and x star is 2. Okay, now it says, oh, and notice I don't need to worry about where the derivative of the function is undefined. So times when we need to worry about a function being undefined are when we might be dividing by 0, taking the square root of a negative number. We don't have any square roots and we don't have any divisions here, so there's no possibility that we're going to have an undefined function. Okay, so now we just need to evaluate the function at the critical points and at the endpoints of the interval. So my critical points and the endpoints are x star is equal to -1, x star is 0, x star is 2, and x star is 4. So -1 and 4 are my endpoints, 0 and 2 are my critical points. Okay, so now I'm going to evaluate the function at those points. So, excuse me, not f. G of -1 is -1 cubed, which is -1, minus 3 times -1 squared, which is 3 times 1, so minus 3, or -4. Now G of 0 is 0 cubed minus 3 0 squared, that's just 0. Okay, now 2, G of 2 is 2 cubed, which is 8, minus 3 times 2 squared, which is 12. So again, I get -4. And finally, G of 4 is 4 cubed, which is 64, minus 3 times 4 squared, which is 3 times 16, or 48. 64 minus 48 is 16. So now they say, using the answers to 1 and 2 above, determine the global minimum, or the absolute minimum, the global maximum, or the absolute maximum, and any local minimum and maximum points of the function. Okay, so let's start with the global max. So here we're looking among all of our critical points and our endpoints for the one that has the biggest function value, right? That's going to be the highest place that the function goes to. And of course here we see 16 is way bigger than -4 or 0. So our global maximum point is 4, 16. Okay, so x equals 4, y equals 16. Okay, oh, and I'm sorry, that should say max. Now let's look at the global min. Okay, now we're looking for the smallest y value, right? The smallest function value. So of course we see we have a -4 here and a -4 here. So our global mins are -1, -4, and 2, -4. Now notice I have 2 here because these functions have the same value, the same function value. These points have the same function value, so they're going to both share the title global min. Okay, and finally we have this last point that we need to classify, and I noticed that x star is, when x star is -1, we have -4, and when x star is 2, we have -4. So 0 between them is higher, right? 0 is bigger than -4, and 0 is between -1 and 2. So I know that my local max is the point 0, 0. Okay, so now let's use all that information to sketch a qualitatively correct picture of the graph of g of x. Okay, so I can first of all put in the points that I know. So I know -1, -4. So I have this point. I know that I have the point 0, 0. And then I know that I have the point 2, -4. Okay. And finally, I know that I have the point 4, 16, which is right here. Okay, so now if we just connect the dots, and notice we know that when we're going through these 2 points that the derivative is 0, so I'm going to draw a little flat line between them to remind myself that I should be coming to a flat derivative, no slope derivative equals to 0, place my curve. Okay, so here we're going flat, and then we come up to meet here. And notice this looks like it should, right? So we have our global mins, the lowest points on our graph are here. Our local max right here, looks like a local max, right? And then our global max is way up here, much higher than everywhere else. Okay.